In this video, we're going to discuss cyanohydrins and hydrates. A cyanohydrin is formed by reacting an aldehyde or a ketone with hydrogen cyanide, which is a toxic gas, to form a cyanohydrin. Now, the important thing about the cyanohydrin is that you have a hydroxyl group and a nitrile group. Both of these groups allow us to do some pretty cool transformations. Therefore, cyanohydrins are synthesis gold. If you can make a cyanohydrin, you have a lot of options that can come out of that. So here are just a couple examples. By taking 2-butanone and reacting it with hydrogen cyanide, we can form a cyanohydrin. The cyanohydrin can be reacted with a strong acid in water to hydrolyze the nitrile into a carboxylic acid. And notice the hydroxyl group is untouched. This gives us what is called an alpha hydroxy acid. Now, if you've used any skincare products in the past like 5 years or so, alpha hydroxy acids have become a really big thing because they used to be largely available in clinical products, but now you can buy them in over-the-counter products such as like the Neutrogena hydrogels. The nitrile can also be reduced using lithium aluminum hydride followed up by water to give us an amine and a hydroxyl group on the same molecule. This would be considered a beta amino alcohol. And then we can also react the cyanohydrin in almost concentrated acid and heat it up. And what this would allow us to do is hydrolyze the nitrile to a carboxylic acid while also eliminating the alcohol through dehydration. And this gives us an alpha beta unsaturated carboxylic acid. Our next topic is hydrates, which can also be called CHEM diols. And these are largely formed from aldehydes. So aldehydes in water are in equilibrium with their hydrates. So if you have an aldehyde and it reacts with water or is dissolved in water, that process is called dissolution, you will form what is called an aldehyde hydrate or a CHEM diol. Remember that CHEM is short for geminal, which means that they are on the same carbon. So this carbon, which is the carbonyl carbon, has 2 hydroxyl groups on it. Therefore, it's called a CHEM diol. And then if water is removed from the compound through distillation, you can isolate the aldehyde. So CHEM diols are not particularly stable. Isolating the diol is actually pretty difficult. The only exception would be something like chloral hydrate, where you have an electron withdrawing group that allows us to stabilize the CHEM diol by pulling electron density away from the rest of the molecule towards the electron withdrawing group. And this is a trick that we'll see a couple times in this chapter, is adding on an electron withdrawing group can help you stabilize something that would otherwise be unstable.